This is Apropos. Scientists are warning that El Nino conditions are set to influence global temperature and rainfall patterns in the coming months, increasing the risk of extreme weather. They say advanced seasonal forecasts and early warnings will be vital when it comes to saving lives and cushioning the impact of the natural phenomenon, which generally occurs every 2 to 7 years. Carol Scarland has more.
In the ocean, the first signs of El Niño are already being registered. The natural phenomenon, which warms sea surface temperatures in the central and eastern Pacific Ocean, occurs every 2 to 7 years. According to the World Meteorological Organization, there's an 80% chance the next event will occur this summer, with major consequences.
In some regions, it is likely we will see heavy rainfall and floods. In others, drought conditions. We can also expect an increased risk of extreme heat with higher temperatures and shifting precipitation patterns, adding further stress on human health, ecosystems, agriculture, and energy systems.
Scientists also say this new episode could be even more severe. The last El Niño in 2023 to 2024, which meteorologists said was strong, contributed to making 2024 the hottest year on record. The WMO is forecasting above-average temperatures in nearly every region of the globe from June through August and beyond.
El Niño conditions will pour fuel on the fire of a warming world. The only effective response is climate action equal to the crisis, ending the addiction to fossil fuels, accelerating the shift to renewables, protecting the most vulnerable, and delivering early warning systems for all.
There's no evidence that climate change increases the frequency or intensity of El Niño events, but it can amplify associated impacts.
Well, to discuss, we're joined now by Dr. Paul Roundy, Professor of Atmospheric and Environmental Sciences at the State University of New York at Albany. Good to have you with us this evening, Paul. Talk to us about El Niño itself, what exactly it is, how it differs from normal climate conditions in the Pacific Ocean, and how it affects weather patterns.
So you need to start thinking along the equator of the eastern Pacific Ocean. In that region, normally the winds are coming from east to west, and because of the rotation of the Earth, that draws up cold water from underneath and creates a cold tongue of water along the East Pacific equator. And at the same time, those trade winds blowing from east to west pile up warm water in the Western Pacific. And over time, that builds up and eventually gets displaced back toward the east. You can think of it like sloshing of the water in a bathtub. The warm water floating on the surface of the ocean heads to the eastern Pacific. And normally it's just a moderate warming over there, and it changes the distribution of rainfall in the tropics. And where it's raining in the tropics, the air comes in, up, and out, and forces changes in the large-scale we call them planetary waves in the atmosphere. These determine where it's warm, where it's cold, where it's wet, where it's dry. And we sit in conditions where some parts of the world are normally dry, but then when El Niño kicks in, they become wet and face flooding and other outcomes. In this particular event, there's a lot of warm water volume available, and it's perhaps more than most past events have had. And just back in April this year, we had strong westerly winds over the Western Pacific that were stronger than any previously recorded event. And these westerly winds happened just to the west of the warmest water. And so they drove an eastward current in the ocean that's moving the warm water that was in the West Pacific toward the east and pushing that normal cold layer that's in the East Pacific down. And this is happening now at a similar rate to what happened in 1997 when we had the strongest event of the last century. And there's some model solutions that are suggesting that this event could achieve an amplitude similar to the strongest event known back in the late 1870s.
So that means we're facing into something that we haven't seen in about 140 years or so. Why is it so strong, Paul? As we say, we normally kind of see this phenomenon every 2 to 7 years. So why do you think this one is going to hit particularly hard?
It's the combination of where the water volume had been accumulated in the Pacific Ocean and where these westerlies were located and the intensity of the westerlies. So they're pushing that warm water from west to east, and that warm water source is roughly half a degree warmer than it was in 1997 during the similar event back then. That warm water will move from west to east across the Pacific, and it will cool a little as it does so. But the models and basic physical arguments, just based on tracking the progress of the warm water as it's moving over the last several weeks, suggest that the amplitude could be as high or potentially higher than any event in the last century.
And we might presume, given the recent heat waves we've had the last few years, and even here in Europe in the last week or two or so, we might presume this is somehow linked to climate change. Is there any evidence that these El Nino events are connected to that? Is our warming planet making them more stronger or more frequent?
There aren't any consistent trends, and climate models aren't particularly good at simulating the rainfall patterns and the wind patterns that drive the observed El Nino conditions. And so it's difficult to be able to predict how this signal will change in response to climate change. But in this particular event, the source water in the Western Pacific is absolutely warmer than it's been historically. And part of the reason why it's warmer is that the climate has warmed in most parts of the world. In El Nino, if we're looking at the contrast between El Nino warm events and La Nina cold events. In La Nina cold events, the East Pacific is colder than normal, and its boundaries are set by the temperature of the water that can be upwelled from deep in the Pacific. And that cold water is the same temperature as it was many decades or even centuries ago. But what's changed is the West Pacific warm water can be higher in response to climate change. Climate change will also impact the rainfall rates along the atmospheric waves that respond and can adjust the amplitude of those features. But the strength of the event itself may have only a small association with climate change.
And the models that you refer to there, is there a risk that they might be underestimating the actual risk linked with the interaction of the two, the El Nino on one hand and global warming on the other? And what should governments be doing to prepare for the possibility that all of this is going to continue to get worse, stronger and more frequent into the future?
So we don't know that El Nino events will become more frequent or even stronger into the future, but there's a possibility that this could happen. But when you're talking about heat events that are generated by El Nino, parts of the world will be cooler than normal in association with the developing event, and parts of the world will be warmer than normal. And those parts that are warmer than normal are stepped up in terms of in comparison with the past because the baseline temperature is higher. But El Nino is a normal, natural phenomenon, and occasionally it becomes extreme. And when it does, we have to face that by preparing in advance. India has historically had severe droughts associated with El Nino events. The 1877 event was associated with a catastrophe in India and China, where as many as 40 million people died. But today, conditions are so much different. The nation of India has put aside large amounts of grains, food stored to make up for this kind of event. China has stored water in reservoirs. Farmers are able to plant crops today that are better suited for drier climates. The ability to transport food around the world is also improved. So it's unlikely that the world will face an extreme famine this year wherein millions of people die. But it's important that we continue to do the things that we're doing today to be prepared for these kinds of outcomes by nations setting aside food supplies, educating their farmers, and providing access to crops that are more resilient.
And Paul, just finally, why do global temperatures then records tend to occur in the same years that we have this El Nino phenomenon?
Normally, the warm water in the West Pacific is concentrated in a geographically narrow region, and it's deep and out of touch with the atmosphere. During El Nino, that warm water spreads out, and that means that the atmosphere is more in contact with that heat, and we'll call it moisture and heat transfer from the ocean into the atmosphere more readily during El Nino. And that leads to the primary spike in global temperature, which is just from warming the tropics. In addition to that, El Nino modifies where it snows and where the winds blow, where it's stormy. And this further alters the incoming solar radiation and other variations, and can then amplify the warming effect associated with El Nino. But contrast this a little bit, but in very strong El Nino events, the storm tracks are stronger over the North Pacific. And these storm tracks are associated with cooling of the water underneath in the North Pacific. And that can offset some of the globally enhanced temperature effects associated with El Nino. So 2023-2024 had a huge global temperature spike, in part because the extratropical, the northern mid-latitude regions of the North Pacific did not cool as much that year. This event is likely to be sufficiently strong that it will be able to extract more heat from the mid-latitude oceans and thereby cool the overall surface temperature and offset some of the extreme tropical warmth that we're going to see. So we will see a strong globally averaged spike in temperature. But I don't foresee a catastrophe associated with that because some of those outcomes will be offset by other effects of the El Nino in the middle latitudes.
Paul, we'll have to leave it there for now. Thank you so much for joining us tonight with your expertise on this subject. That's Dr. Paul Roundy, Professor of Atmospheric and Environmental Sciences at the State University of New York.